All right, today we're looking at the labs for Module 3. As you can see, we are going to be doing two different exercises, Exercise 6 and Exercise C. So the first half of this is going to be taking a look at the information you need for Exercise 6, where we will be covering isolines. What is an isoline? An isoline is one of the most important lines that you'll see on maps that will help to convey important information. Specifically, isolines are lines that join equal points of value that are separated by predetermined intervals, and they are useful for a variety of things. Isolines are used to determine and indicate and show differences between things like temperature, precipitation, and elevation. One important thing to note about an isoline is that isolines are always closed lines, meaning that they have a start and an end, and that they will never cross over each other. So taking a look at this example map, we can see that we have these lines that are defined and they're showing us different levels of annual precipitation. So even where a line doesn't go clearly across the map, you'll have little sections that are cut out, but each of these areas are going to be a clearly defined area of annual precipitation, again identifiable by these different colors, that are all dependent on the isoline marking the differences between these data. Again, this is just one example, so let's go ahead and take a look at three more. These types of isolines, including contour lines, isotherms, and isobars, are going to be the three most important isolines that we're going to be dealing with in our physical geography course. So, some of you may be familiar with this already, but a contour line is basically a line, is an isoline that exists on a map, generally a topographic map, that shows us differences in elevation. Again, that is the example presented here. So this map down here, the red lines are the isolines, specifically contour lines, showing us changes in elevation. And so you can see that all the way down here where we have this valley floor, it shows us that there's a gradual or no change in elevation, which is why the lines are spread far apart. And you can pay attention to how the elevation here increases. And if you look at these isolines, these contour lines are going to reflect those changes in elevation where you're going from an area of lower elevation up the mountain to areas of higher elevation. And again, here you can see the top because this is the highest point of elevation. So in addition to the contour lines, which we can see here, we have isotherms and isobars. Isotherms are lines that will show us variation and lines of temperature, and isobars are going to show us points of equal atmospheric pressure. So we'll have plenty of labs dealing more closely with isobars. But here is a quick example showing us the difference between the showing us the difference between the isobars and the isotherms. So an isobar, again, is looking at atmospheric pressure. So if you've paid attention to your local weatherman or weather person, you may be familiar with a low pressure system and seeing these lines of atmospheric pressure, as well as if you're looking at the daily temperature that we might be experiencing in our home city or even on a nation scale. You can see how each line here represents every point where the temperature of 85 degrees or 80 degrees exists. So it's important to note that these lines will never cross over one another and that they are connecting every point of 85 degrees that is visible on this map. So how are we using isolines for this week's lab? We are more or less going to have to identify and construct our own isolines using information and data points that are going to exist on a map. In order to construct our isolines, we are going to have to start with often just data points, and we're going to have to go through here and construct the lines accurately detailing our predetermined intervals. If we decide that each interval, each isoline, or in this case it's going to be a contour line since we're dealing with elevation, if we determine that each line is going to be 5 feet apart or 5 meters apart, then we're going to make sure that we're going to draw an isoline that represents the elevation changes for every 5 meters in elevation change. So we have to use the data points attributed here and do our best to draw the lines that best associate with 115 meters, 120 meters, 125, and 130 meters. So ultimately, we can take a sheet of data points, draw our isolines with our predetermined intervals, and in essence draw a two-dimensional representation of a three-dimensional area on a two-dimensional sheet of paper. So jumping into our exercise 6, which again you can find in the lab manual, you'll notice again that we are dealing with different types of isolines, and specifically they are highlighting contour lines, isotherms, and isobars, which again we have examples for you up here. Contour lines, isotherms, and isobars. And again, one way to keep this in mind is that thermal basically just means heat, so you can keep that in mind knowing that isotherms deal with changes in temperature. And you are going to be tasked with connecting different points to draw correct or identify incorrect isolines. So let's go ahead and jump into an example. Before we dive deeper into this, another component that needs to be mentioned is that we are often going to be tasked with interpolation. It's basically the process of estimating unknown values that fall between known values. So again, this practice image has been taken straight from your lab manual, and I've provided an example, the red lines, as to where we might interpolate the data existing for isotherms at 15 degrees, 25 degrees, and 35 degrees. So again, we don't have a specific data point that shows us 15 or 25 or the 35, so we have to use the data around us to try and figure out exactly where these isotherms might exist. And you can see that when we are drawing these isotherms, they are going to have to contour or move with the data points around them. So putting just a straight line through here, even though it would have fit, would be less accurate, just because you could tell that there is going to be some sort of bend in here depending on the other data points. So try and visualize this one. These are data points that I've come up with, and I want you to try and figure out where you might draw your line to indicate an isotherm at 10 degrees as well as an isotherm at 25 degrees. I've already gone ahead and shown you where the isotherm at 30 degrees would most likely exist. So take a minute, go ahead and pause the video if you need to, and try and visualize this by yourself. Alright, let's go ahead and take a look at the answer. I've also provided a few more examples of where the lines might most accurately be to represent the data on this map. So as you can see, our 10 degrees is probably going to need to have some sort of curve through here, as well as our 20 degrees is going to want to curve around and stick really close to this data point of 21, as well as get relatively close to this 23. So you can see that with the data points that exist on this map, there is going to be a natural sense of curvature. So again, down here and up top here, you'll see the actual temperatures represented along these isolines. So this is the quick and simple explanation of using the data points that exist in order to accurately draw your isolines, keeping in mind that they are not going to be straight lines for the most part. And you need to pay attention to the intervals that you've been given to make sure that you draw the isolines on the correct data points, as well as do your best to accurately interpolate the data for unknown data. Again, there's plenty of additional information in your lab manual. Otherwise, feel free to reach out to me via Canvas inbox if there's a specific question that I can help you with. Go ahead and click on the video for the following exercise, exercise C, to get a little bit of help with that as well. Thanks.